somewhere around there. But actually, when you did the, well, yeah. So I've done this example for a line, but you could easily do it for something else. All right. So finally, for today, one other topic. It's pretty easy. It's called the closed interval method. And I'll just give you an example of it. Suppose we had f of x equal to x to the fourth minus x cubed on, let's say, minus 1 to 2. Find min-max. So what the closed interval method says is just this. If you have a continuous function, all right, on a closed interval, you can find, well, first of all, the extreme value theorem says that the minimum and maximum are attained. Closed interval method says you can check the endpoints and then check any critical points, and the max and the min has to be at those points, one of those points. So like, f of minus 1 is what? Minus 1 minus what's 2, right? What's f of 2? 16 minus 8? 8. All right, so those are two contestants in the battle for min-max. All right? Next, we look for critical points, which, since this function is differentiable, we just need to look for where df dx, which is 4x cubed minus 3x squared equals to 0. Right? So this one, I can factor out x squared. I've got 4x minus 3 equals to 0. What are my critical numbers? My critical numbers are at 0 and x equals to 3/4. Those are my critical numbers. So those are the other contestants in the game of winners and losers here. So I need to calculate f of 0, which is what? 0. And f of 3/4, what's that? It's 3/4 to the 4th power minus 3/4 to the 3rd power, which is 81 minus 4 times 27. 4 times 27 is what? 108. And we divide by 4 to the 4th, which is otherwise known as 256, I think. 16 times 16. I made a common denominator in the second fraction so I could combine them. The point is that that's what, like, what's 81 minus 108? Negative 27. So we got minus 27, if I haven't made an arithmetic mistake, over 256, right? So that's approximately negative 0.1? Or you're telling me exactly minus 0.1 what? 0.105. All right. So, behold, these are our choices. F of 0 equals to 0. F of 3/4 is minus 0.105. F of 2 is 8. F of minus 1 is 2. The closed interval method says the minimum and the maximum for f on that interval are in this list. So what is the min? The minimum was minus 1.105. It was attained at 3/4. Is 3/4 in that interval? It is, right? What's the maximum? Maximum is 8. It was attained at 2. 2 is an endpoint. So basically, the closed interval method simply says this. If you're looking at a model or a function and you want to minimize and maximize it, if your context has endpoints, you want to look for critical points that are within the context of your variable, and you want to look at endpoints. You compare these, and the maximum and the minimum has to be in that list, provided the function is continuous. If the function is not continuous, then funny stuff can happen, like we've seen already. But anyway, we'll do more of these later. I just wanted to do one today since it was on the topic list. But so Friday we have a lab, but